So in the previous video, in order for us to see our artwork, we had to change the main camera scale. By default, it was set to 5. Now, if we were to move something closer to the camera, you'll see that it's incredibly large. And again, remember, this is because all of our artwork is a 1-for-1 ratio to units in Unity. So each one of these units is now a pixel. Well, at different resolutions on different devices, we're not going to be able to maintain a consistent look and feel. So in order to fix that, we're going to create a script that will allow us to automatically resize the camera based on the height of the screen that it's being played on. To do this, we're going to create a new folder to store our scripts. Then inside of this, we're going to create a new C# script, and we're going to call it Pixel Perfect Camera. Now let's open up this script inside of MonoDevelop. Now if you're new to writing scripts in Unity, every time you create a new script, this is the basic layout. What you'll see is that we have classes that we're importing from the Mono framework. We have the class that we're creating itself defined here with the class block, the name of the class that we created. All of our classes extend Mono behavior. Now they don't have to, but when you create one from Unity itself, it's going to want to extend Mono behavior so it'll work within the framework. And then you're automatically given some scaffolding code. There's a start method and an update method. The start method is usually where you set up things in your class, and the update is what happens on each frame before draw gets called. Now our camera is going to be a little special. Since we only have one camera in the game, we're going to want to create some static properties so that other classes in the game can access the scale that we start calculating based on the screen resolution. First, we're going to want to keep track of the pixels to unit ratio that we set up for our artwork. In this case, let's make a public static float, and we'll call this pixels to units. And let's make this equal 1, and let's add an F at the end to denote that this number is a float. Next, we'll need another public static property to represent the scale. We'll just assume that scale is always 1 when we start out. Now, we're not going to actually need the start and update methods. We're going to take advantage of a method that gets called before start. This is going to be critical for our camera because we want the camera to calculate the scale of the game before anything else starts. So in order to do this, let's change start to awake, and let's remove the update method. We can also delete this comment. And we're going to add one more public property. This public property is going to represent the native resolution of our game. In this case, we're going to make a vector2, and we're going to call this native resolution. And let's set this to a new vector, and we'll make it 240 by 160. Now, this happens to be the resolution of a Game Boy Advance. Since we're working in pixel art, I usually try to pick systems that relate to the artwork that I'm using and their native resolution. Ideally, the way that this works is that a 1-for-1 ratio where our artwork looks exactly how we intended it to be when we designed it would be if the native resolution was 240 by 160. But of course, there's no device now that runs at a resolution that low. So what we're going to have to do is calculate the difference in scale and scale up the values in our game. In this case, what we'll do is when we recalculate the scale based on the resolution of the device we're playing, we're simply going to change the size of the camera so that it zooms in more to maintain that look. So to get started, let's get a reference to the camera we're going to be working with. We're going to attach this script to the camera itself, so we'll be able to use a method called getComponent. Here, we'll get a reference to the camera, and we'll use getComponent. And this is called a generic, so we can pass in any type that we want. In this case, we're going to pass in camera, and we're going to close this method. Now that we have a reference to the camera, we want to make sure that the camera is set to orthographic. When you set Unity into 2D mode, orthographic should automatically be set. So here, let's do camera.orthographic, and this should return either true or false. If we're in orthographic mode, what we need to do is take the current height of the screen and divide it by the native height resolution, and this is how we'll get our scale. Next, we'll want to modify the pixels to units so that it relates to the scale in the game. Now, we're not really changing this pixels to unit value throughout the game. It's not like we're updating the artwork. This is just simply something that we can use later on as a reference point to know, well, the pixels to units now is a lot larger because we're on a bigger resolution. So now we need to change the size of the orthographic camera. The way that we're going to do that is by first getting half of the screen's resolution. In Unity, the 0 position is actually the middle of the screen. So when we get the height, we actually need half of that height to represent what we need to do for the scale. So in this case, we're going to divide it by a float of 2. Then, once we have half of the height of the screen, we're going to again divide this by the pixels to units. Remember, this is the pixels to units that we just calculated. It's not the real pixels to units. At this point, everything should be set up. Let's save our script, go back into Unity, and now we're going to drag the Pixel Perfect camera over to our main camera. Now you'll see that it's still set at 5. If we were to change the resolution by going into the Game tab and selecting Standalone and running the game, you'll see that size will now be changed to 80 and all of our artwork will look crystal clear. One thing to note, though, is that if you change the resolution while you were running the game, this script wouldn't automatically update. So it's important to know that this only runs the first time we actually run our game. Now, we can move on and start looking at building out our scene and start adding things like the background into our game. Also, make sure you save the scene and all the changes that we've made.